Ninth problem. Two spherical balls of 1 kg and 4 kg are separated by a distance of 12 centimeters. Find the distance of a point from the 1 kg mass at which the gravitational force on any mass becomes 0. Okay, so two spherical balls of 1 kg and 4 kg are separated by a distance of 12 centimeters. Okay, two spherical balls. This is one spherical ball, that is m1 is equal to 1 kg is given, and there is one more spherical ball, and it is its mass is m2 is equal to 4 kg, I think. Yes, 4 kg. Then these two are separated by a distance of 12 centimeters. These two are separated by 12 centimeters, that is center to center distance. Okay, then we find the distance of a point from the 1 kg mass at which the gravitational force on any mass becomes 0. From the 1 kg of mass, somewhere the total gravitational force will become 0, and that point is now we have to find out that distance from the 1 kg of mass. Okay, between these two gravitational forces, somewhere the gravitational force by the 1 kg and gravitational force by the 4 kg both are same and opposite in direction. That's why the resultant force is here equal to 0. And at what distance from the 1 kg of mass, that resultant force on any mass is equal to 0. Then the distance we are taken as here x. If force resultant force is 0 at x, then write down here, and whatever the distance from here to here, the total distance between the center to center is 12 centimeters. Then from this part, okay, up to from here, it is equal to how much? 12 minus x is the distance. Okay, so it is m1 kg, and this is for m2 kg, that is equal to 4 kg. From the m2 kg, at 12 minus x distance, the force of attraction will be 0. From the 1 kg of mass, at x is equal to x distance, the resultant force will be 0. Okay, so then write down it as, for suppose, if the resultant force, if the resultant force 0 from the resultant force 0 at x from the resultant force is 0 at distance x from 1 kg mass. Okay, so then force by the 1 kg of mass at that distance, that is equal to how much? Force by 1 kg is equal to, that is g m1 m2 by r square, and that is equal to how much? G m1 is equal to this one, that is equal to 1 kg into, and here we are keeping one object, that is mass m, and its mass is m, by r is the distance from the 1 kg. 1 kg, from the 1 kg distance, it is equal to x, but the distance between the two objects is 12 centimeters, that is different. And from this 1 kg, how much distance is there? Up to where the force is 0, that is equal to x. So that's why it is x square. Okay, so this is equal to gm by x square. Like that, force by the 4 kg mass, okay, that is g m1 is equal to this 4 kg, and m2 is equal to, if you are keeping an object here, that is m, and this is m. Okay, by this is, what is the distance here from this mass to where the force is 0? The distance is 12 minus x, so it is 12 minus x whole square. then that is equal to, this is 4gm by 12 minus x whole square. So according to the question, here where the force is equal to 0, the gravitational force by the 4 kg mass and 1 kg mass is cancelled each other. So that means these two are same at that distance. That is, force by the 1 kg is equal to force by the 4 kg. Their magnitudes are same and opposite in direction at this distance. So that's why the resultant force is equal to 0. So that's why we are equating their magnitudes. So if we are equating their magnitudes, that is left-handed side, that is gm by x square, is equal to right-handed side, that is 4gm by 12 minus x whole square. Okay, so then 1gm cancel. If those cancel, it is equal to 1 by x square here, and it is equal to, this is 4 by 12 minus x whole square. By doing the cross multiplication, 12 minus x whole square is equal to 4x square. If you are taking the square root on both sides, square root on both sides, then it is equal to how much? 12 minus x is equal to 2x. Then this x we are taking to the side, 12 is equal to 3x, 3 ones are 3 fours are, so x is equal to 4 meters. Okay, this is at from the 1 kg of mass at 4 meters, the resultant force will be 0.